We're going to learn about making measurements with significant figures. Significant figures, for short, is often referred to as Sig Figs, and significant digits and significant figures are the same thing. All the digits that can be known precisely in a measurement plus one last estimated digit are all going to be considered my significant figures. If I were to look at these example rulers, notice the first ruler, I have no markings between 0 and 100. So I am basically estimating right off the bat that maybe this is about 20 centimeters in length. So my significant figures are everything that I know precisely plus one estimated or guessed digit. So since the 2 in my 20 is already my guessed digit, there is only one significant figure in this number, and that would be the 2. In this estimate, in this ruler, we could say for sure that it's 20, and then I have to guess a little more. 20 what? And maybe we'll say it's 22. But that's as far as I can go. I can't estimate any further than that. I don't have any more lines to go by. So what I'm sure about is that it's at least 20. So this is a certain digit. And then what I'm estimating is that it's 22. And so this is going to be my estimated value, and both of these will be considered significant. So this has 2 significant digits. Last one, I have more increments provided for me. So I know for sure that it's at least 20, and I know for sure that it's at least 21, 22, it's at least 22, and now notice that I can guess one more digit between these two lines. So this is going to be 22 point maybe 2 or 3. And so that last number, once you have estimated or guessed a number, that's it. You can't go any further. You can't estimate more than once between the lines. And so we're going to say that this is 22.3 centimeters. So I'm sure it's 20. I'm certain it's 22. I'm certain that it's 22, but I'm guessing it's 0.3. So all 3 of these are considered my significant figures or sig figs. Every precise digit that the instrument tells you plus one more, which is the digit that you estimate, are all going to be your significant figures. So in this example, I know for sure the 7. That would be my first significant digit. And then I'm going to guess or estimate one more digit, that it's 7 point something, maybe 7.6. So on this metric ruler, you know the 7 for sure. You will estimate one more digit. This measurement is going to have 2 significant figures, the 7 and that 0.5. You, the person doing the measuring, must always include your estimated digit. If the measurement is not between 2 values, you must still show your estimated digit with a 0. So if I'll look here, the meniscus, first of all, is the bottom of a liquid inside of a graduated cylinder or a beaker, and that bottom of the dip is what you read on a graduated cylinder. So here is the bottom of the meniscus, and I'm going to estimate that it is right on the 30. Okay, however, you can't just put that it's 30 because this is accurate to the first decimal place. We have to put that it's 30.0 and not just 30. Because I could read this as 30, 31, and then anything in between this would be one estimated digit, that means this is accurate to the tens place, so we have to read it that far. So consider that anytime you have a measurement that lands on the dash, right on the line, there should always be one more 0 after that number. So let's take another little example here. If I happen to land between the lines here, then I would read this as 30, 31, and then I'd have to estimate one more between the lines, 31.5, and so therefore this number would have 3 significant digits, the 3, the 1, and the 5. So let's read a few more graduated cylinders. So here is the bottom of the dip or the meniscus. So this goes 85, 86, 87, 88, 89, 90. So that means that this right here is going to be 88. And I have to guess now, what is this between 88 and 89? And maybe you guess that it's about halfway in between, so it's 88.5. 3 significant digits. Over here, notice that it lands right on the line. So we're going to end up with a 0 after we read this measurement. We have 90, 91. It's right on the 92, but can't say just 92. We have to say 92.0 is the correct measurement here. All right, lastly, this one also lands right on the line. So it's on the 90, and then we're going to have to tack on one more zero, 90.0. And I've zoomed in a little bit closer for you. Notice here that it's 30, and if I want to go backwards, it's 29, and that's 28. So since this is kind of halfway between 28 and 29, I'm going to call it 28.5. Now, be careful because you can only estimate one time between the lines, so don't keep estimating. Like, we're not going to put a zero on the end of this one, and especially because it didn't land right on the line. We only add that extra zero when we're right on the line. When I read this graduated cylinder, notice we're a little bit zoomed in over here. We're going to read the bottom of the dip, which puts me just about perfectly in between these two lines. It goes 15, 16, 17, 18, 19, 20. So this is going to be 17, and then I got to estimate between the lines 17.5. Okay, what about this beaker? Which digits can be precisely known in the beaker? Well, I know that this is 40, I know this is 50, I know this is 60. So I know the tens place for sure. So I know it's at least 40. The estimated value is going to be that one more number in between. So I know for sure that it's 40, and I'm going to estimate that too, that it's 42. This is the known value. This is the estimated value. Both of them are significant, so this measurement has two significant figures. Now let's look at how to read a quadruple beam balance. So you're going to have to do a bit of adding, and first I'm going to notice here is 100. Here it's at the 20. And here it's at the 8. So that's 100 plus 20 plus 8 equals 128. Point. Down here it goes 0, 0.1, 0.2, 0.3. So I know it's between the 0.1 and the 0.2, so we'll say 0.1. It's past the 0.1 but not past the 0.2. Now each of these lines in between is my next decimal place. So this is going to go 0.11, 0.12, 0.13, 0.14, 0.15, 0.16, 0.17, 0.18, 0.19. So I know that it's past the 0.19. And the last thing that I have to do is estimate one time between the lines for my final digit. So we'll say that this is a 1 there. So my final answer is 128.191. If I look here, we have 200 plus 0 plus 5. So that's going to be 205. Point. And here I know that it's past the 0.5 but before the 0.6, so 0.5. And now it's in the very center, so this is 0.51, 0.52, 0.53, 0.54, 0.55. And now I simply need to estimate one more digit. If you look closely, you'll see that it is right on the line. And when it's right on the line, we just need to add a 0. Lastly, here we have 0 plus 90 plus 0, so that's just going to be 90. Point. And now we're at 0.1, 2, 3, 4, 5, 6, 7, 8. It's right on the 0.9. Now this one is tricky because it's right on the 0.9, but remember that we still have these little guys, so that's 0.91, 0.92, 0.93, but it's right on the 0.9, so I'm going to need another 0 here, and then we're going to need one more 0 because this is accurate to the thousandths place. We'll read these graduated cylinders. This is 60, and these go up by increments of 1, so this is 61, 62, 63, 64, 65, and then I have to estimate one more between the lines, so 65.5 down here. Next, that's a 20, which means this right here must be where 10 is, so this is going to be 10, 11, 12, 13, 14, 15, but when it's right on the line, you got to add that one more 0, so it's going to be 15.0. This one is 70, 71, 2, 3, 4, 5, 6. It's right on the line, so it's going to be 76, and I'm going to add that 0.0. So each of these readings has 3 significant figures. One is certain and one estimated digit.